This is the Physical Science Exam 2015 and this is question 16. Complete the following table. This is into the organic chemistry style of things, so we're going to be able to have a look at this. We have 1-bromo, 3-methyl-butane. So if we're going to have a bit of a look at that, we have a look at our organic chemistry page. Let me have a look here. What we have is we have, of our alkanes, we have alkenes, alkynes, and alkanes. Well, alkanes are here. Now we know it's butane. Butane is of that form, and remember that butanes, or that alkanes only have one bond before the carbon. So we've got butane. But is going to be 4, so we're going to have 4 carbons. Carbon, 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 carbon. Right, what have we got next? 3-methyl-butane. So what that means is we have a look at our side chains. We have a methyl, we just have a side chain here. Let me see, 1, 2, 3. So we can come off the side there, 3 methyl and 1 bromo. So 1 bromo. With our side chains and substitutes, we've got our substitutes here, bromo. We've got that one there. Coming off the first one, that's 1, so it's going to be bromo. Now remembering that carbon has 4 bonds, so each one of those is going to have bonds like that. 1, 2, 3, 4, 1, 2, 3, 4, so that one's going to be bound to that. So just fill up the empty ones with hydrogens. There we go. Now we need to got the structural formula for this one, and we need to give it a name. We see that it has got a double bond in the middle. So if it's a double bond, it's going to be an alkene. Now, with this one, it's going to be a bit trickier because we could just, it would want us to go 1, 2, 3, 4, 5, 6, 7 straight across there. But we need to look for the longest chain. And the longest chain of carbons is 1, 2, 3, 4, 5, 6, 7, 8. So it is going to be 8. Now, what that means is if that is going to be the chain through there, there are going to be side chains here, and there's going to be a side chain here. This one is the side chain that is going to be closest to the start, so we'll call that 1, and that is going to be 2, 3, 4, 5, well that's going to be 3, that one there with the double bond coming off it, 4, 5, 6 there, and what we have there is we're going to have 8 of these, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be octene, but it's going to be oct3ene because it's going through there. So it's going to be oct3ene. And in front of that, we've got a methyl group. That's a methyl group. We've got a methyl group on 2 and 3, 4, 5, 6. So we've got 2, 6 dimethyl. There's 2 of them. So 2, 6 dimethyl oct3ene. Very good. Pentene. So it's going to be a double bond in one of these. Cyclopent is going to be 5. So we've got the cyclo one. We've got pent is going to be 5 of them, and it's going to be in a row. So what that means is if we're going to have that, we're going to have a carbon, a carbon, a carbon, a carbon, and a carbon. And that one can be number 1, and because it isn't stated there, so we'll just make that the double bond. So 1, 2, 3, 4, 5. 1, we're going to have 1 chloro coming off there. 1, 2, 3, 4. And we're going to have ethyl. Ethyl is a double chain, or it's a 2 carbon chain. 1, 2, 3, 4. That one comes off there. We have C2H5. Now 1, 2, 3, 4. That one's full. 1, 2, 3. We'll have 1 off that. 1, 2. We'll have a couple of hydrogens off that. 1, 2, 3. A hydrogen off that one. 1, 2, 3, 4. hydrogens off that one, and that should be fine. Draw and name two isomers of the organic compound whose molecular formula is C3H5Cl. Choose one saturated isomer and one unsaturated isomer. Remembering saturated means it's going to be an alkane. Okay, there's going to be no double or triple bonds. And unsaturated means it's going to be either an alkane or, either be an alkene or an alkyne. So let me have a look here. How are we going to do that? If we were to look at that, we would see it's got 3 carbons. 3 carbons and 5 hydrogens and 1 chlorine. The chlorine has substituted in for one of the hydrogens, so it's the equivalent of 3 carbons and 6 hydrogens. If we come back up here and have a look at our various types of algorithms for our organic chemistry, if it was to be a straight chain alkane, 3, it would need to have 2 times 3, 6, 8 there, but we've only got 6. If we look at our cyclic alkane, if we had 3 there and 6 there, that's going to work. If we're looking at our unsaturated alkanes, so either alkenes, again, this one's going to be an alkene. So what we can do there is choose draw and name. So we're going to draw these. Let us do the saturated one. That's going to be a cyclic. It's going to be C, 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 and it's going to be looking a little bit like that. Let's draw one with H, H, Cl, H, H, H. Now the thing about this one is that you can rotate it any way, and all it has is this one off here. So what that means is there's no need for numbers or anything like that. We can just put down chloro, cyclo, 1, 2, 3. If we've got 3 of those, we're going to have propane, cyclopropane. Now, for our unsaturated isomer, we're going to choose an alkene so that we get those. So let us say that we have C, C, and a C, and we shall put our double bond there, because if we don't, we'll have to make this one number 1, because it's going to go through there, and we're going to have a carbon, and we can either have a chlorine coming off this one, or this one. Let's have it coming off here. 1, 2, 3. We need one more to come off there. 1, 2. There's going to be a single bond through there. 1, 2, 3. So we need one more coming off there. 1, 2, 3, 4. Hydrogen, hydrogen, hydrogen. So in this case, we're going to have, this is prop. I'm surprised I put pro. Let's see, it could be prop-1-ene, or you could just have propene because it's only got that one there. It's going to have 1 chloro prop-1-ene, and that's fine. And question 16 continues over the page. State a test that could be used to identify the unsaturated isomer in part B. Well, what we have there with our unsaturated isomer is it's going to cause a rapid decolorization if we add a bromine, if it goes in with bromine. In other words, what's going to happen if we add Br and Br, if we add a bromine, let me see, if I add then it will break down that bond and it will connect a bromine to there and a bromine to there. So it would have a rapid, now here we go, we can draw that over here. So a test that would use that to unsaturated element would be add Br2 to see if it would rapidly, not radishly, rapidly discolor or decolor. And we would see what that would actually look like, and that would be an addition reaction. because what we would have there is we would have C, 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 and we would have a chlorine off there and a hydrogen off there. 1, 2, 3, 4. That one off there. Hydrogen, 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 plus Br2. So this is going to split up, and that is going to give you, that's going to break down. So we're going to have C, C, C. One of those bonds will give it up. H, H, and we would have, no, sorry, that's not an H, it's not going to be an H. That is going to be a chlorine, Cl, and then there's going to be one bromine there, and we're going to have, still have the H there, we're going to have one bromine there, and we're going to have H, H, H. Carbon exists as a range of allotropes. Ooh. Explain the meaning of the term allotrope, giving 3 examples of the allotropes of carbon. Okay, this is where it's always wise to take in a dictionary. Now, I don't know if you can see this or not, and you certainly wouldn't have to necessarily bring in the new, shorter Oxford Dictionary, but this is the only one I could find at home. Oh, oh no, it's all gone pear-shaped. But I'll put that out of the way. And I don't know if you can see this, but it talks about allotrope, and under here it says the existence in the same state of more than one form of the same element with different properties. So that's what it means. So that would get you thinking about what different types of solid carbon, they're in the same state. So let me see, we only know carbon as a solid. What different types of solid carbon are there? Explain the meaning of the term allotrope. Well, we could just write out that explanation. It's variations of the same element in the same state with various different properties. So for instance, if you're going to look at carbon, the 3 that I'm looking at, and they're probably the 3 that you know, are going to be diamond, solid carbon, graphite, and you could use buckyballs. So we have that. Or if you wanted to, there are also carbon nanotubes, which are a different kettle of fish altogether. So describe the different structures of 2 allotropes of carbon, explaining how their differing structures relate to 2 of their physical properties. All right, well, let's go with diamond and let's go with graphite. So diamond is a covalent network of carbon atoms. It's a solid. Describe the different structures. Is a covalent network, so each carbon atom covalently bonded to the next to give strength, and gives to give strength, and for instance, and no delocalized electrons. Therefore not conductive. Graphite is a, what is it? It forms plates with strong strong covalent bonds along the plate but weaker between plates. Weaker bonds provide allow movement, so graphite feels slippery and delocalized electrons allow graphite to be a conductor. There you go. And that's question 16.